It's me, Mario!
Hello guys, we are the
Bytecodes!
and I'm the leader of this group. My name is Emmanuel Dimisola.
My name is Jemani Sean Gabriel Pentingue.
My name is Jared Domnes.
And my name is Raji and Declaro.
And
Let's
let's
do
do
Arduino 101!
Hello everyone, this is our Arduino project number 13, which is the motor fan. So how we're going to do is, we're going to control a small fan using a relay module and a push button. So the fan motor is powered through the relay, which acts as a switch controlled by the Arduino. When the button is pressed, the relay toggles is state turning the fan on or off. So here we have the materials. So here we have the DF Arduino Uno R3. It is a compact microcontroller board based on the Atmega 328P, compatible with the Arduino IDE. It features color-coded headers for easy sensor connections and supports digital and analog inputs, making it perfect for learning, prototyping, and development. Here we have the prototype shield. It is involved using an Arduino board, sensors, actuators, and code to create a functional mock-up of a device or a system. Next, we have jumper cables, male-to-male. They are essential wires used in electronics to connect components on a breadboard or between modules. So male-to-male jumpers cables are flexible wires with male connectors on both ends, used to link electronic components during prototyping and circuit testing. Next, we have 220R ohms resistor. It is a safety component that controls the flow of electricity current in Arduino projects, especially for LEDs. Here we have the 5mm LED. So it is on a Arduino Uno. It's a light indicator that shows the Arduino's output, but it must be used with a resistor to limit current. So here we have the relay. So the relay is a electrical controlled switch. It allows the Arduino, which works at low voltage such as 5 volts, to control devices that need higher voltage or current like lamps, fans, or motors. The Arduino sends a small signal to the relay coil, and the relay then opens or closes its switch to turn the external device on or off. Here we have the push button. So it is a simple switch that connects or disconnects a circuit when you press it. On an Arduino Uno, it is used as an input device. When pressed, it sends a signal, high or low, that the Arduino can detect and respond to, like turning on an LED, starting a motor, or triggered an action in the program. Here we have the 130 motor. A 130 DC motor is a small lightweight motor component used in toys and simple Arduino projects. When they're connected through a motor driver or transistor circuit, the Arduino can control its speed and direction. It converts electrical energy into rotational motion, making it useful for spinning wheels, fans, or small mechanisms. And of course, here we have the fan. So a fan is a small motor with blades that move air when powered on an Arduino Uno. So a fan can be controlled through a transistor, relay, or motor driver. Since the Arduino alone cannot supply enough current, the Arduino can turn the fan on and off or adjust its speed using PWM, often used in temperature-based projects like automatic cooling systems.
Hello guys, so this is the AP13, which is the motor fan, by using the relay. So first, we're just going to declare the value or the digital pin connected to the Arduino. So button pin is 2 and the relay pin is 3. Then by declaring the initial state of the relay, if it's on, is high. Then the button state for the current reading that we're going to store this. Then after that, the last button state, which is low, if the button is not pressed, or the previous button reading for comparison. Then after that, long variable last debounce time. This is the time stop of the last button, that state change. Then debounce delay, which is the delay to filter out button noise in milliseconds. So we're just gonna do that. Then after that, we're just going to do in the setup function is doing the button as an input, button pin as an input, and the relay pin as an output. Then digital write, so relay pin, and then relay state, which is high. So we're just going to initialize the relay with the default state, which is high, so fan on. So after that, in the loop function, we're just going to read the current state of the button. So by reading the button pin, then storing that into a variable called reading integer, we're going to do an if statement. So the condition is reading is not last button state. If the button is button reading has changed due to press or noise, then reset the debounce timer. If it's not, go to the next. So if the reading has stayed stable beyond the debounce delay, so this is going to do this kind of code. Just checking if the reading stayed stable. So milliseconds minus last debounce time, then is greater than debounce delay. Then if the stable reading is different from the last confirmed button state, then the condition will be reading is not button state, then button state equal reading, which is the digital button pin read. So we're just storing the reading to the button state. Then after that, next, if the button is pressed, which is button high if is pressed, then relay state is not relay state, which is going to flip the relay state to on and off if it's the button state is pressed. So toggle the relay state. Then after that, apply the relay state to the output pin. This is the relay state pin, then relay state, which is the high, which is the default which is the default digital write in the setup function default state. Then after that, we're going to save the current reading for the next loop iteration by just storing the reading to the last button state. This will just continuously running from time to time, just checking the button is pressed or not. Then if it's pressed, then click the button of the relay, then on and off. That's pretty much it.